Welcome back to STS. In today's video, we need to find the area bounded by the parabola described here at F and the line G also defined here. We begin by trying to find the intersection points, and we do that by setting these two functions equal to each other. So here we have 2 minus x squared is equal to x minus 4. Let's go ahead and try to put everything on one side so that we can try to factor. To do that, let's move all these terms here to the right. So let's subtract 2x and add x squared. So minus 2x plus x squared. And in doing so, these terms here cancel. And I'm left with, I'm going to actually switch this around. I'm going to have x squared plus x. And here minus 4 minus 2 gives me a minus 6, and all that's set equal to 0. Now I can factor. I'm going to have an x. I need the factors of 6 that are going to add up to a positive 1. Well, those factors are going to be 3 and 2. When I add these, I need it positive, so the larger number has to be positive, the smaller number negative. And again, when I multiply, they have different signs, so the outcome is going to be negative. Now that I have my two factors, I need to set each factor equal to 0. So x plus 3 equals 0, so that tells me x is equal to negative 3. And x minus 2 equals 0, so that tells me x is equal to a positive 2. So now I have the boundaries or the limits that I need to place on my integral. Now let's go ahead and do a basic sketch of what we expect here. We're told it's a parabola. Again, we know that because it's second degree. This parabola here is actually going to be facing down because the coefficient is negative, and we see that it has a vertical shift of 2 units. So we know we're going to be up here at 2 units, and it's going to actually open. It's going to actually open downward. All right, and I'm going to go ahead and label this F. We know that g of x is a line. They told us that, but again, we see it is linear, and we see we have a slope of 1, and we have an x-intercept of negative 4. Let's say this position here is negative 4, so it's going to go through like such. And what we know is that one of the intersections here, this intersection here is at negative 3, and this intersection here is at a positive 2. So the area in question is going to be found in this region here. All right, so let's begin by going ahead and let's set up our integral. So we know the integral is going to go from lower bound of negative 3, upper bound of 2, and we're going to place in our functions, but we need to figure out which function is larger. Is it function f or is it function g? Well, we can look here and we see that over the interval negative 3 to 2, we see that function f is at the top, so function f has to be listed first. If you weren't able to do the graph to actually see it, you can input a value. What we're going to do is, just for example's sake, a number between negative 3 and 2, the easiest number to pick would be 0. So we're going to take f of 0, and that would leave us with a positive 2. And we're going to take g of 0, and that will leave us with a negative 4. And again, we see that the 2 is greater than 4, so that means function f has to be listed first. So here function f is 2 minus x squared, and we need to subtract off the function g, which is x minus 4. Can't forget these parentheses because we have two terms here. We need to make sure that the negative is applied to both of these terms. And now we're going to rewrite to simplify. Again, we're going from negative 3 to 2. So I have 2 minus x squared minus x plus 4 dx. And again, rewrite for simplification. I keep my negative x squared. I keep the negative x. And I have a 2 plus 4 to give me a positive 6 dx. Now I can integrate. I keep my negative, so that x squared integrates to x cubed over 3. Again, I keep my negative. X becomes x squared over 2, and then the 6 becomes a 6x, and this here has to be integrated, or I'm sorry, has to be evaluated from negative 3 to 2. What I want to do, you know what? Yeah, I'll go ahead and do my I'll go ahead and do the substitutions. We always substitute in the upper bound first. So I have a negative, and then 2 cubed is 8, so this is negative 8 thirds. Let me fix that. This here is a negative One more time. Let's do this neatly. A negative 8/3 minus 2 squared is 4, and then 4 divided by 2 is 2, and then 6 times 2 gives me a positive 12. Then I need to subtract off the lower bound. The lower bound is I have a negative 3. Well, a negative 3 to the third is a negative 27, but that's already negative, so that's going to be a positive 27. And then 27 divided by 3 gives me 9. And then here I have a negative 3 squared is 9, so that's going to be 9 halves. And then here I have 6 times negative 3 to give me a negative 18. At this point, let's try to do some simplification. I see I have the negative 8/3, but I have negative 2 plus 12 to give me a positive 10. And actually, let's go ahead and make that 10. Let's make that 30 over. Let's make that 30 over 3, because 30 divided by 3 is 10. And then let's see what we need to subtract off. Let's see, 9 minus 18 is a negative 9. And then I've got the minus 9 halves. But let's go ahead and change this negative 9. Let's change that into actually a negative 18, because we know that 18 divided by 2 is going to give me the 9 that I had there. And now I can add these first two together. So negative 8 plus 30 is actually a positive 22 thirds minus. And here I've got a negative 18 and a negative 9 to give me a negative 27. But it's going to be positive because I have a negative out here. So this is going to be a positive 27 over 2. And now let's get a common denominator of 6. So I'm going to come up here. So for this to be 6, and I want this here also to be 6, well, that's going to be 3 times 2 gives me 6, so 2 times 2 gives me 44. And then over here, 3 times 2 gives me 6, so now I need to do 27 times 3. Well, that's 21, 6, and that's 81. So I have 81 over 6. And then at this point, I need to add the 81 and the 44. Well, the 4 and the 1 give me 5, and the 8 and the 4 give me 125, and then my denominator is 6, and this here is in square units. We're going to call up the calculator and now figure out what this is in its decimal form, and then also just evaluate to make sure everything we did here was correct. Alright, so with the calculator, we ended up with 125 divided by 6. And that there comes out to, like with the 20, I'm going to round this off to 20 and 8/10. So let's go back and put that in place. So this here is also 20 and 8/10 units. And then back to the calculator, let's go to y equals. Here you see that I have both the parabola and the straight line already here in the graphing section. So let's go ahead and graph it and see what it looks like. Here we have the both of them. We set our limits, or our boundaries went from negative 3 to positive 2 on our x-axis, so let's go ahead and do that. So negative 3 is the minimum, and then positive 2 is the maximum. Let's take a look at that. All right, we have a lot of free space, so let's go, let's 1, 2, 3. Let's make the make the y maximum 3 and the y minimum 1, 2, 3, 4, 5, 6, 7, 8. So let's go from a negative 8 to a positive 3 on the y-axis. So let's see, negative 8, and then the max is going to be a positive 3. And let's take a look at that. Alright, so that's that there in place, so we can get a better look at that. And then let's go back to y equals. And now let's put these two functions in as we said. We said the parabola was the larger one, so that there is y sub 1. So I'm going to do alpha and press trace to get to f4. I want number 1 to give me y sub 1, and I need to subtract off the second equation. So again, alpha and then trace to get to function 4. I want to press number 2 to get y sub 2, which is a straight line. And now I want to go back to graph. And actually, you know what? I need to zoom out some. So let's do zoom. Let's go back to standard. So zoom 6 standard so we can see everything again. And let's come in one more time. Again, let's go from -3 to +2. So let's do window. The minimum is -3. The maximum is +2. And then let's graph. Alright, that there's a little skewed, but we're going to work with that. Here we see that the area, or the area of the region between the blue and the red, which is here, is being shown as the black curve and the x-axis. So we're going to take that. We're going to take the integration or the integral, or we're going to integrate this black curve. So here, let's go to second and then trace. Let's go down to 7. And we said the lower boundary was -3 and the upper boundary was 2. And whoops, I didn't do it for the right curve. Let's do that one more time. Let's do second and then trace. When I click on 7, I need to make sure I'm on the black curve. So on the black curve, I see it now. Y sub 3 is equal to the parabola minus the line. The lower limit we set was -3, and the upper limit we set was 2. And now when it does the integration, let's see what our result is. Our result does come in as that 20 and 8/10 over the interval, or over the boundary -3 to 2, just like we calculated by hand. Alright, that sums up this video by Speller Tutorial Services. Please friend us on Facebook and also subscribe to that YouTube channel. And as always, thank you for watching.